Hi, this is the Science Chef. In this video, we continue with our solution to the Cambridge IGCSE Chemistry Paper 4 for May-June 2020. We will be solving question number 2. If you'd like to see our solution to question 1, kindly check the link in the description. Now question 2. Question 2 says magnesium is a metal. That is a keyword there. Magnesium is a what? Metal means that we should be expecting questions on what? Metals, metallic bonding, compounds of metals, reactions of metals, or reactions of compounds of what? Metals and their likes, and also what? Anything that has to do with a periodic what? Table. We should be expecting questions around those areas. The question says, name and describe the bonding in magnesium. Remember, we are told that magnesium is a what? Metal. So the bonding they are asking for is the bonding in magnesium what? Metal. Remember, there are types of bonding. You have ionic bonding. You have ionic bonding, or that's what we call what? Electrovalent what? Bonding, which is formed with the bond formed what? Between two oppositely what? The force of attraction formed between two oppositely what? Charged ions, right? Or is a bond that occurs between two oppositely charged ions as a result of what? Complete transfer of what? Of electrons. Fine. Now we can also have what? Covalent what? Bonding. That's based on IG scheme. Covalent bonding here has to do with what? Sharing of what? Sharing of pairs of what? Equal pairs of valence electrons, right? Fine. And we also have what? Metallic what? Bonding. We also have metallic bonding. This one occurs between what? Metals, or within metals, right? It occurs within metals. While these two, ionic and covalent bonding, will lead to the formation of new products, metallic bonding does not lead to the formation of a new product because it occurs within the metal itself, right? So any metal that you know of contains what, or has what, or exhibits what? Metallic bonding, right? So since magnesium is a metal, then the bonding in magnesium is metallic bonding. Metallic bonding. Coming back to this, ionic bonding occurs, or electrovalent bonding occurs between metals and non-metals, metallic atoms and non-metallic atoms, while covalent bonding occurs between two or more non-metals. Now for metallic bonding occurs within metals. Please take note of that. Now how do we describe metallic bonding? It's a force of what? Attraction. It is a force of attraction between what? Between the positive what? Ions. Between positive what? Metallic what? Ions. And what? And a sea of the localized electrons. Remember, the bonding is different from metallic what? Lattice. We were told to define a metallic what? Lattice. It will be what? A regular what? Arrangement. Metallic lattice is what? A regular arrangement of what? Of positive what? Ions. Thus you have this regular arrangement of positive ions. These are all positive ions of the metal in a what? In a sea of what? Localized electrons. That's mobile electrons that are free to move about. These mobile electrons are responsible for the conduction of electricity or heat, or transfer of what? Heat, because they carry the charges from one point to another in the metal, right? So since we're looking at this is metallic lattice, regular arrangement of positive ions in a sea of the localized what? Electrons. But for bonding, it is the force of what? Attraction. Force of attraction, that's the key here, keyword here. Force of attraction between the opposite what? Metallic what? Ions. Opposite metallic ions and what? A sea of the localized what? Electrons. It's actually electrostatic, since it involves two oppositely charged particles, right? So you can see this what is the electrostatic what? Force of attraction. You can just, let's add this, the electrostatic force of attraction between the opposite, the positive metallic ions and a sea of the localized electrons. So that's where you get your 4 marks. There, 1 mark here, 1 mark for positive ions, 1 mark for sea of the localized electrons, and 1 mark for metallic what? Bonding. All right. Now, magnesium oxide is formed when magnesium bonds in oxygen, right? So you can see that this question is already on what do you call it? On chemical what? Combination or bonding. So complete the dot and cross diagram to show the electron configuration of the ions in magnesium what? The inner shells have been what? Drawn. Give the charges on the ions. Fine. So you're going to complete the what? The dot and cross diagram to show the electron arrangement of the ions. Fine. They've given us the inner shell. So magnesium, first off, magnesium is what? Magnesium has atomic number what? 12. That's 12 electrons, right? When it is what? Neutral. So for it to form, this is 2, 8 what? 2. So for it to form an ion, what will it do? It will lose these 2 electrons. That's magnesium 12 minus 2 electrons will become what? Magnesium what? 2 plus, right? 12 here. Fine. So which means that the charge here first is what? 2 plus, right? And so how many electrons will we have left from our formula? That electrons is equal to what? P minus what? Charge, right? That will give us what? Number of protons is 12. Our charge is what? Plus 2, right? That's 12 minus 2. That gives us what? 10. So what will be the electron configuration? Electron configuration here will be what? 2, 8. And they've drawn the inner shell for us. So we are now to draw the outer what? Shell, right? And you can see the symbol for the used to represent the electron from the magnesium what? Atom. We are told to use what? Dot and what? Cross. So the dot represents the magnesium what? Electrons. So 1, 2, 3, 4, 5, 6, 7, 8, right? So that gives us the magnesium what? Ion. And now oxygen. Oxygen is what? 8. Oxygen is 8. That's what? 2, 6, right? Oxygen is 8. That's 2, 6. Now, so what will it do to form an ion? It will do what? Gain 2 electrons to form what? O2 what? Minus. O2 minus. So still 8. So it means that its number of electrons here will be what? P minus Q. That's what? 8 minus 2. That gives us what? 10. So first of all, let's write the charge here. This 2 minus, okay? So from this will be the electronic configuration 2, 8, right? So inner shell has already been drawn for us, so you have to complete the outer. Since there are just 2 shells, you complete the outer shell. And there are 8 electrons in the outer shell, and we are going to use the cross symbol to complete that. Good. So from here, so we've answered that question already. 3 marks. So 1 mark for the charges, correct charges. 1 mark each for the correctly drawn outer shell of magnesium and oxide ions. Okay. And of course, when I say correctly drawn, using the correct representation, using the dot for magnesium and cross for oxygen. Now write the chemical equation for the reaction that occurs when magnesium bonds in what? Oxygen. Chemical equation. So magnesium here bonds, that's the combustion reaction in oxygen to give us what? Magnesium oxide. How do we get this magnesium oxide? Indirectly, they are trying to tell me to write the formula for magnesium what? Oxide. Really, not necessarily, because I think you were given the formula of magnesium oxide here. Fine. So magnesium bonds in oxygen to give magnesium oxide. Now balance. How many atoms of magnesium do you have here? 1. How many do you have here? 1. How many oxygen atoms do you have here? 2. How many do you have here? 1. So what do? We multiply by what? 2. We balance equation using what? Coefficient. So now that we multiply this by 2, it has affected the number of magnesium atoms on the right hand side. So what do we do here? We also multiply this by what? 2, and everything is balanced. Remember, if you don't know the state symbols, just be silent on it. It's not necessary, except you are categorically what? Asked to add the state what? Symbols. Now magnesium oxide also forms when magnesium nitrate is heated what? Strongly. This is an endothermic what? Reaction. Yes, because the decomposition, heat is absorbed. It is absorbed to break the what? Compound. Now write the chemical equation for this what? Reaction. Remember, all nitrates undergo what? Thermal decomposition. That was the break up into what? 2 or more what? Products when they are what? Heated. We made a video on types of reactions, which includes decomposition reactions. So if you want to learn more about types of chemical reactions, you can watch that video. We've added the link in the description. So MgNO3 2 to give us what? MgO plus NO2 plus O2, right? So what does this mean? Magnesium nitrate undergoes decomposition to form the oxide, thermal decomposition to form the oxide, nitrogen dioxide and oxygen what? Gas. Not just magnesium, but from, we have potassium, sodium, calcium down to copper, right? Then silver. Now these two guys will give us what we call what? The nitrite plus what? Oxygen when they decompose. Well, this one's calcium, from calcium to copper will give us what? The oxide. We decompose what? The oxide plus nitrogen dioxide plus oxygen when they decompose. Well, this one will give us what? The metal. Magnesium from silver down will give us the metal plus nitrogen dioxide and oxygen gas when they decompose. So that's what we are using here. That knowledge is what we are using here to answer the question. Fine. So remember, you have to balance this. So let's balance. Magnesium 1, okay, nitrogen 1 here on the left hand side, nitrogen 1 here is balanced, oxygen 6 here, oxygen 5 here. So what do we do? How can we make this 2? Okay, so let's make this 2. We make this 2. Fine, so we have 2, that's 6. And now magnesium is now 2. So we now add 2 here. Remember, when balancing equation, most times it's trial and error method. That's what you use. So now that we've done that here, what has happened? Nitrogen is now what? 4. 2 times 2, that's 4. So we now add 4 here. Definitely we expect it to affect oxygen again, but let's see whether now that nitrogen and magnesium are balanced, let's see whether oxygen will still be balanced too. So oxygen here is now what? 3 times 2, 6. 6 times 2, that's 12. I mean 12, yeah. Now here 2, this is 2. 4 times 2, 8. 8 plus 2, 10. 10 plus 2, 12. We are good to go. Fine, we are good. Okay, so what type of reaction is this? This is, like we stated earlier, this is what is a thermal decomposition. We need to add that thermal because it only occurs in the presence of what? Heat. As you can see from the question, it's strongly what? Heated or heated strongly. So that's thermal decomposition. Right. Name 2 other compounds of magnesium that form magnesium oxide when heated. Based on your IG syllabus, right, the compounds of magnesium that undergo decomposition are magnesium nitrate, magnesium carbonate, and magnesium hydroxide. Now all of them will undergo decomposition to give us what? Magnesium oxide. Right? They all undergo decomposition to give us magnesium oxide. Before we answer that question, let's look at how each of them decomposes. We've already seen magnesium nitrate. So for magnesium carbonate, it will give us, it will compose to give us what? Magnesium oxide and carbon dioxide, right? While magnesium hydroxide will give us what? Magnesium oxide and what? Water, right? So that's that, which means that based on this question, 2 other compounds of magnesium that form magnesium oxide when heated are magnesium what? Remember, you're asked to what? Name, not formula. So write the name. Magnesium. The compounds are magnesium carbonate, and magnesium what? And magnesium hydroxide. Magnesium carbonate and magnesium hydroxide. So that brings us to the end of question 2 for the Cambridge IGCSE Chemistry Paper 4 for May-June 2020. If you're able to learn anything from this tutorial, like this video, drop a comment, and subscribe to this channel if this is your first time here. Also, you can always join our membership club, have access to exclusive videos, live tutorials, and live chats, where you have the privilege of asking questions on any challenging topic on chemistry. Rest assured that you'll be answered. A wise man once said, "What you don't prepare for won't give you time to respond." So like the Boy Scout, be prepared till I see you when I'll see you.